Okay, so I'm doing unit 25 and 26, which is indefinite integration or antiderivatives and use substitution. So the basic rule for indefinite integration is to increase the exponent of the variable by 1 and divide the term by the new exponent and add a plus c at the end of the answer to represent the unknown constant. So things to remember for regular integration is to change the radicals to exponents. So if you have square root of x, you would change that to x to the power of half, and then you would add the plus 1 divided by whatever you get. Separate coefficients from variables. So if you have 2 over x cubed plus 5 over x, you would take out the 2 in the 5, so you would end up with 2 times 1 over x cubed plus 5 times 1 over x. And then it'd be easier for you to bring up the x and do the addition and stuff. Using the FOIL method, so if you have 3x plus 7 squared, FOIL it out, because then you would have individual terms, which will be easier for you to add to the exponent and divide. And split functions into individual fractions. So if you have 5x plus 18 over square root of x, you could split them, so you would have 5x over square root of x plus 18 over square root of x. Easier for you to bring up the x and the x. Okay, so for use substitution, the main points are to find and identify the u, which is usually the hardest part of the function. Sometimes it's not, but usually it is. It can be found in the parentheses or under a radical or as a denominator. So when you find the u, derive it and make it equal to dx. Plug in u and dx into the original function and then solve. So the goal is to cancel out du with the part that you didn't change in the original function. So some examples are, so the first example would be, what I have is square root of cosine 6x sine 6x dx. So the u for this question would be cosine 6x. I mean, if cosine 6x doesn't work out and you can't cancel anything out in the answer, you would go back again and do it with sine 6x, but the answer worked out. So the dx would be du over negative sine 6x, because I did the derivative of cosine 6x. Plug it back into the original formula, so you would have square root of u times sine 6x times du over negative 6 sine 6x. Cancel out the sine 6x's, you'd be left with square root of u times du over negative 6. Now you do the integration for square root of u, so you would have u square root of 3 divided by 3 over 2 times du over negative 6. And then when you simplify that, you would have 2u 3 over 2 over 3 times du over negative 6. You can simplify the 2 and the 6. So the answer would be cosine 6x to the power of 3 over 2 plus 9 plus c. For the next question, 2x over square root of 2x minus 1. So the u would be 2x minus 1, and then dx equals du over 2. So plug in the u, so you'd have 2x over square root of u times du over 2. The u's can cancel out, so you'd be left with x times u to the power of negative half times du, which you can simplify that. So x squared over 2 times u half over 1 over 2, you integrate. So you integrate it, not simplify it. And now you simplify it, and the answer would be x squared, and then in parentheses 2x minus 1, which was the u, to the power of half plus c. Okay, for this question, 8 minus x over square root of x squared minus 16x minus pi. The u would be the denominator, so the dx would be 2u over 2x minus 16, which is the derivative of this. 8 minus, so here I plugged in the u, so 8 minus x over square root of u times du over 2x minus 16. So over here you can simplify the 2x minus 16 to cancel out with the 8 minus x. So I just changed the sign over here with so it would be the same. And so they canceled out, and I'm left with 1 over square root of u times du over 2. And then when I do the and when I integrate this, I have negative u 1 over 2 divided by 1 over 2 times d over u. And so when I simplify this, the 2's cancel out, and then I'm left with negative x squared minus 16x minus pi to the power of half plus c. And then for the last question, this actually looks really hard, but everything really cancels out in the end. So it's 3x plus 15 times square root of x squared plus 10x plus 4 dx. So the dx is du over 2x plus 10. So when I plug that in, I plug that in, and it's 3x plus 15 times square root of u times du over 2x plus 10. When I simplify this, these two can cancel out, and so it's 3 times square root of u times du over 2. And yeah, so I do the antiderivative of this, and so over here you can see that the 3 over 3 here cancels out with this, and the 2 cancels out with the du over 2. So the answer would be x squared plus 10x plus 4 to the power of 3 over 2 plus c.